If you have any questions, then I'll have more time to answer your questions if they are specific, especially. Very well. First, we're going to talk about how applications are built at the high level. Okay. In particular, we're going to define two very important terms. And we need to know what these two terms mean for us to make sense of the other concepts that will be introduced. Then, this is an important one, an overview of programming languages. There are many programming languages, and it's not always straightforward or easy to decide which programming language you should choose. Now, this question is true whether you are a beginner to programming, meaning you've never written a line of code, or even if you're someone who's experienced. This question always comes up. Should I switch to another programming language? Is this the right programming language? Should I try another one? So I will talk about the different variety that exists and how you should go about choosing your next programming language. This is this is also for those who've never written code before. And I just noticed Katerina joined us. Welcome, Katerina. Now, irrespective of which programming language you choose, there are two concepts with which you must be familiar: algorithms and data structures. I don't know if you've heard of these words before, but we will define these also. Algorithms and data structures are even more important than the previous question, which is which programming language should you choose. Let me say that again. It is more important for you to be familiar, very familiar with algorithms and data structures than it is than programming languages. So it's such a central concept, not just in programming, but in computer science, more broadly speaking. And then after we talk about these concepts, I will open the session for any questions that you may have, questions about what we're covering today, or any questions you have in general. Right? Very good. Let's try to understand how programming languages work. Now, I want you to imagine writing down instructions for a person, another human being. How would you instruct them to do something? Now, of course, we're all here on Meetup, so we're here to learn a skill. So let's use learning a skill on Meetup as an example for the analogy that I'm about to give. Here's how it works. You open the Meetup website, you browse the website or the app, you scroll up and down, and you look for a title, an event that might be of use to you, like this introductory or like this mini class. And then you select it. You RSVP, and then like now you will attend it, and you'll perhaps take notes or ask questions, and you will continue to learn a new skill, right? So you find a new skill, then you participate, you learn the new skill, and then after the workshop is over, you investigate this further. You explore this further. You try to master the new skills. Now, these skills that I've written, okay, imagine this was a program written. This was a program. By the way, when we say program, the word program, this is one of those concepts I told you that are very important, refers to a file that contains instructions in the form of a programming language. So these are instructions written in programming language. If you were to give me instructions, or if I were to give you instructions, these instructions would be written in spoken language, like English or Arabic or German, what have you. Okay? And those instructions could be in an email or a text message. When it comes to computers, those instructions are written in a file which we call a program. Okay? That's the first of those two words. The other word is process, which I'm going to come to in a second. So program and process, keep this in mind. I'll come to that in a minute. Now, humans, right? We are the most intelligent species that we know of. We haven't yet encountered aliens, so at this point, we consider ourselves the most intelligent. Uh, we can give a step like find new skill, and then the human can figure the rest out. Like that one step, that step number one, can translate into 20 or 30 or 50 more steps. For example, if I were to say find a new skill, uh, what would that translate into? It would translate into you picking up your phone, swiping on the screen, clicking on the meetup icon, waiting for it to open, entering some query in the search bar, scrolling down. You see what I'm going with this? So you have to break down the instructions when you want to accomplish this step. Although we don't need to think about this consciously, we just do it. This is not how it works with computers, though. Okay? So if you look here on the right, the code that this we call this pseudocode, imaginary code that you see here on the right is supposed to be a translation. So on the left we have instructions written in a way that a human being can understand. On the right we have instructions written in a way that a computer can understand. Right. So the left could be like an email. The one on the right is a program. Again, which I said is a file in which you have instructions written in with the programming language. So even though we have 3 lines in here, just like we have in the other uh, here on the left, in reality, these lines translate into tens or 20 or even hundreds of lines. So that one instruction must be broken down into very, uh, very, what do you call it? Clear and detailed and simple instructions. Okay. However, even though with a program, you need to detail everything the computer must do, the syntax, the language is very uh, readable. Okay. The way we write programming languages are not very dissimilar from how we write in English. There are some differences, like there are some rules you have to follow. So, for example, if you see here on the right, we have these parentheses, we have these quotation marks, we use these equal signs. So we have these things we call programming constructs, which I'm going to talk about in a second. But it is not difficult to learn. Now, that's not the whole story. What I showed you in the previous slide is what we call a high-level programming language. You see, in computer science, we have different types of programming language categories. 2 of them are important. We have something called a high-level programming language and a low-level programming language. A high-level programming language is the example I showed you in the previous slide. Everything is written in English. Like you can make sense of what's going on. If I bring you back to the slide, you can see we have this thing we call a function, find a new skill. And we're saying find a new skill piano, like find a new skill, find a new piano skill. And then we have a learn new skill. Then we have master new skill. So there's no space in there, but if you pay attention to it for a brief moment, you can make sense of what's going. You can see what this program is about, even if you've never seen a program language before. Now, that is true for a high-level programming language, not so for what we call a low-level programming language. So a low-level programming language is typically not what you as a human being would write. A low-level programming language is one step before binary. So if you look at this slide here, we have 3 boxes, yes? The one at the far left is an example of programming language that is high level, meaning it's very easy for a human being to understand. It then compiles into something we call machine code or low-level programming language. This is not something that is easy to understand. Back in the day when high-level programming languages did not exist, this is how computer scientists would have to instruct the computer with commands like you see, like push and move and pop. And if you wanted to program a computer, you would have to understand computer architecture. So not only would you have to understand the programming language, but how the computer would process the programming language, which is not the case nowadays. If you go on YouTube or if you pick up a textbook, all of those programming languages like Java and Python and JavaScript and PHP and Ruby, these are all high-level programming languages. You do not need to know computer architecture in order to build an application. Whereas back in the day when high-level programming languages did not exist, you did have to understand computer architecture. And if you go even before that, you had to understand binary, which means you had to know how those individual electronic components would turn your program into electrical signals. Again, that's not something we have to worry about. So, typically when people have not had any exposure to programming languages, they imagine themselves running binary code, like in the movie Matrix, or some of you may have watched Mr. Robot. It's not the case at all. So if I go back to the point I made earlier, that you need to explain every little step to a computer, you will do it indirectly. In other words, you write the high-level programming language, and your operating system will take care of translating the high-level programming language to low-level programming language, and from there to binary. So in short, it is only this part that you need to be familiar with, not the others. Very good. So now that I've told you about high-level programming languages, let's look at some examples of these high-level programming languages. And this is not an exhaustive list. This is not all of the programming language, but these are very popular ones. And probably some of you are familiar with this. We have Python, we have Java, we have JavaScript, C++. C++ is a special high-level programming language in the sense that it's also used for low-level programming, but it is still a high-level programming language nonetheless. C#, PHP, and others. How many of you recognize the programming language that I've listed in here? If you recognize any of these, type in the name of the programming language that you recognize. Has anyone worked with JavaScript or Java or Python? Katerina? Gauri Shankar? I know you said you're a designer, but have you seen the code before? Do you recognize the names of these programming languages?
Of course, I recognize the names, but no idea about this.
Okay, so let me quickly. Sandeep says Java, JavaScript. Okay, look, so Sandeep, you do have quite some experience. So now, if you're a beginner, your question is, all right, how do I choose the programming languages? Now, there are two. We said high-level programming language, right? Within high-level programming language, we have two types of high-level programming languages. These are programming languages that are easy for you to learn, but there are two types to choose from. The first type is what we call a general purpose programming language. Okay? General purpose. And the other category is specific purpose. What's the difference? General purpose programming languages are used for building all kinds of applications. Most applications on most types of computers can be programmed with high-level programming languages that are also general purpose. For example, Python. Python is used for many applications. You can use Python for developing applications on the operating system. You can use Python for building web applications. You can use Python for data science. You can use Python for IoT. You can use Python for gaming. So it's a general purpose language, and that's what it means. You can use this. You can learn this one programming language and build applications on different platforms, on different computers, laptops, tablets, smartwatches even. Another one is JavaScript. JavaScript is yet another general purpose programming language. Others include C++. So C++ is truly a general purpose programming language. Most desktop applications are programmed with C++, like Photoshop, Excel, even the operating system. The Mac operating system, the Windows operating system, the Linux operating systems, these are programmed in C++. Airplanes are programmed in C and C++. Uh, Traffic systems, uh, CCTV cameras, so embedded systems are programmed in C++. Then you have programming languages that are meant for specific purposes, meaning you cannot learn this programming language and build a website with it. For example, if you look here down here, we have this programming language called R. R is used specifically for statistics. That's the only thing it's used for. And it's very good for statistics, but it's only confined to statistics. You then have others like PHP. PHP is used for web services. You cannot build UI components with PHP, but you can build all kinds of web services. So we have this spectrum. Some programming languages are very specific. Some programming languages are a bit broader, and then some, go all the way. At this current point in the history of technology, JavaScript is the most general programming language. Meaning, if you want to pick a programming language with which you can do many things, right now it's JavaScript. And in second place is Python. Okay. So let me just say this to you right now. If you've never programmed before and you want to start to learn how to program, you want to choose either one of these, either JavaScript or Python. And your decision depends on the following. Are you going to be leaning towards building applications, or are you going to be dealing with data? Right now, these two areas are dominant. You're either going to build a software product, like a social media application or some sort of application to solve a business problem. Or no, you're trying to you're trying to deal with data and get into machine learning and data science and artificial intelligence. So while both of them are broad, and you can use both for either areas, JavaScript is better for application development. Python is better for data science. There's one more thing. No matter which programming language you choose to learn, if you learn one programming language, okay, if you learn one high-level programming language to be specific, it is easier for you to learn any other high-level programming language, because all programming languages, and if you look at my screen here, all of the ones that I've listed here have many things in common. In particular, they have programming constructs. They all have these things we call programming construct. They all have them. Maybe the syntax is a bit different. Maybe they use different characters here and there, but they all have these programming constructs. What are programming constructs? Well, I'll take you to the next slide and you'll see what I mean. But just take a note of this. You either want to learn JavaScript or Python. They're both very easy to learn, especially JavaScript. With JavaScript, you don't even have to download anything. You can go to your browser, open something we call the console panel, and you can start programming right away. Okay, and there are plenty of tutorials on YouTube that can get you up and running in 30 minutes. We can start to learn in 30 minutes. Okay. Now, remember what I said about programs? Programs are files that are programs that are files in which you write instructions. And those instructions are written in a language we call programming language. Now, programs, when they start to run, when you double click a program, and a program, it has an exe extension or a DMG extension if you're a Mac, but you can also have a CPP extension or a PY extension. Okay, my point is, if you open these program files and the computer starts to run them, it then becomes what we call a process. So if you have a program, which are files, and you run these files, these programs start to run and they turn into processes. And what you see here on my screen are a very small example of the different types of programs that you can write. And let me take a step back. Every electronic device, every electronic device, from smartphones to refrigerators to the gates at the parking to cameras to uh, lighting systems, audio systems, you name it. Every electronic device today is controlled by software. It's controlled by a programming language, right? So just think about that for a second. Think about that for a second. Computers are not just laptops or smartphones. They include cameras. For example, the webcam from which you're watching this video right now. It includes the light that I have in front of me, the air conditioner, right? The air conditioner also, your Bluetooth speakers, your smartwatch. These are all computers. So, and they're all around us, these computer devices, and they're all controlled by programming languages. So even though I'm going to give you some examples, just to understand, you can do a lot more with programming languages than the examples that I'm about to give you. But nonetheless, if you were to learn JavaScript or Python, either one of these are some of the things you could build with these programming languages. Web applications, like uh, Instagram, Facebook, the Amazon website, the YouTube website, the Netflix website. I mean, these are Twitter. These are high value companies. We all know this. And their main product is an application or a program, right? Their uh, their flagship product, the thing that brings them all of this revenue, is a program. So web apps are an example, but you also have desktop applications. I give examples of like Photoshop or Microsoft Word or Google, Microsoft Excel sheets, right? These are desktop applications. You need to download them onto desktop before you can run them. Video games. These are also examples of desktop applications. Mobile applications, of course. Right now, we just confined to two mobile platforms, namely iOS and Android. Internet of Things, these are smart devices. Any smart device that connects to the internet, that's what we call an IoT device. You can program these with JavaScript and Python. Blockchain. Now, blockchain is an idea. If you're not familiar with this, I won't talk about it right now. Maybe if you're curious, I can answer this towards the end of the workshop. But it extends beyond these, from media streaming. So if you want to stream content like pictures and videos and audios, again, you can achieve this with these two programming languages. Machine learning. Anyone familiar with machine learning? Machine learning is about automating human intelligence. Automating human intelligence. For example, looking at a picture and recognizing the contents of the picture, listening to an audio file and identifying the message, the words that are being sent. Okay, and self-driving cars, uh, disease detection, algorithmic trading. Like machine learning is what you do after, is the next level. So programming language allow us to instruct computers. Machine learning allows the computer to think for itself, so to speak. Okay. Scientific computing. So if you've heard of mathematical modeling, or generally speaking, if there are applications in science, you can again, for example, determining the trajectory of a rocket. That's also done in scientific embedded systems, again, like CCTV cameras, traffic light systems, electronic gates, elevators. These are examples of embedded systems. TV screens, these are also embedded systems. Autonomous vehicles, like I said, self-driving cars, self-piloted piloted helicopters. That's something that's also happening. And of course, many examples of financial tech. But again, anything anything that's an electronic device can be programmed by software. But I just put this in here so you have so you can just start thinking about the things you can do. If you learn either one of these programming languages, you can achieve any of these. Okay. Of course, if you understand the domain, you most certainly can build an application for any of these platforms, for any of these purposes. And again, this diagram demonstrates how it would work. So you would pick your high-level programming language. Now, by the way, if you want to build an iOS application specifically, you must learn Objective-C. Okay. So while it's possible for you to build iOS applications with Python or JavaScript, the native programming language of iOS is Objective-C. Conversely, for Android, it's Java. But again, Python, Objective-C, JavaScript, and Java, syntactically, they're very similar to each other. Okay, but nonetheless, you would write your high-level programming language, and the operating system that is running on any of these computer devices would take care of converting it to binary. So again, I'm trying to stress this idea that you don't need to understand low-level programming language. You don't need to understand computer architecture. You don't need to understand binary in order to become a programmer. Okay. And the same is true for the other programming languages that are used for different purposes. But I just wanted to add something which is not here in the slide. These two programming languages, JavaScript and Python, actually could be run on most of these computer devices you see in front of you. Okay, we even have examples of robots that are being programmed with JavaScript. So again, I know I've said this several times now, but your next step after this workshop is to either learn JavaScript or Python. JavaScript if you are interested in building applications, Python if you're interested in dealing with data and machine learning. And you can do both at the same time, by the way. It doesn't mean that you have to dedicate 3 months learning one programming language. You can learn both at the same time because they're so similar to each other. So you can learn Python and JavaScript simultaneously. In fact, that's what we do in our coding bootcamp. We teach both programming languages. But anyway, this following topic, data structures and algorithms. These two things are intertwined. In particular, data structures. If you want to become a competent software developer, okay, it's one thing to know how to code. It's another thing to be a master. Someone who can write algorithms that are efficient, that are useful. And perhaps you may even consider changing careers. If you see yourself becoming a software developer entering software development as a profession or data science as a profession, more important than the programming language you choose to learn is the following concept. You ready? Let's see what this is about. And in order for me to explain what data structures are, I need to explain to you, just at the high level, how applications work. Okay? So this is where our understanding of programs and processes come into play. Every computer device has three main components. Every computer has three components. Again, smartphones, laptops, desktop computers, smartwatches, they have these three main components. The first one is the processing unit, which we know as CPU. But other types of processing units include GPUs. But CPU is the main one. Then there are two types of storage. There is something called permanent storage, which is your SSD drive, your optical drive, your flash drive. And if you go back a decade, it would include CDs. And even before that, it would have floppy disks. They're called permanent storage because once you write data to these processing storage components, they will remain there even when you turn off the computer and you unplug the cables. Okay. Then we have something called temporary storage. And it's called temporary because the data lives on this component so long as the computer is running. That third one is very important, especially for someone who wants to write software, who wants to give instructions to a computer. Temporary storage is something important. So if you want to become a professional and an expert in building applications, you need to understand temporary storage. So even though I said you don't need to understand computer architecture, if you want to become a professional and expert, you do need to understand computer architecture. And the most important for a software developer, the most important component in the computer's architecture is the temporary storage. Let's see how this works. So you have your program, which we set as a file in which you have instructions written in a programming language, like the one you see here on the left. So let's say we have a program for registering a user on a website. The user will fill out their information, their first name, last name, email, and then we have a program that will take this information, process it, save it to the database. Okay? Now we don't need to worry about the code here, just how temporary storage plays a role. So we have a program, right? And this one is JavaScript. We run this program. We run the program, and then here's what's going to happen. The first processing unit, the first unit I told you about, which is the processing unit, or as we know as CPU, will start to read this file and take certain pieces of information from this file and write it. Write it to temporary storage. So for example, information like the date, the user's email, this Boolean value like true and false will be written into temporary storage. Okay? And here's a better example. I want you to imagine a video game. And you're playing a video game, right? So when you run the program and the video game loads, let's think about a game like Super Mario. Although the example I'm giving you works for any kind of application, even Excel sheets or whatever, but Super Mario. Now, the Super Mario game has a lot of instructions, but some information from that program is going to be written in temporary storage. For example, the background, right? You have the main character, and then you have the background in which this character is operating. It's going forward, it's going backward, it's jumping up and down. Now, that video game has different stages. Stage 1, stage 2, and you have music playing. But music, you have different music that plays in different stages. And the background changes when you enter different stages. When this character moves to a second stage, the CPU is going to go back to that program and it's going to bring in more information into temporary storage. The old information in temporary storage is going to be cleared out, and new information is going to be written in its place. And if I use the Excel sheet as an example, let's say you have an Excel sheet with 10,000 rows. Okay? So in this scenario, your program is an XLX file with 10,000 rows in it. When you open that Excel document, you're not going to get those 10,000 rows at once, right? Because temporary storage, unlike permanent storage, has small space. The amount of space you have is much lesser than that on temporary and permanent storage. So the computer has to be careful and has to be clever with how it manages the space. So what happens is when you open the Excel sheet, you will see the first 1,000 rows. Okay? When you scroll down and you move past 1,000, what the computer will do is it will start to bring in the other 1,000 rows. And you will keep on scrolling until you reach row 2,000. And after that point, the computer will start to bring in more information from that file. Why does it do this? Well, because if you were to wait for all of those 10,000 rows to load, you'd be waiting a long time. In fact, you may not even have space to load all of that information. In some cases, when you scroll down too far, the computer will take out those first 1,000, 2,000 rows to make room for more of those, Excel rows. This is important because this temporary storage is not just used for one or two applications, but all of your applications are going to be using this temporary storage. So the computer, the operating system, must manage this traffic, must manage this load. What does this have to do with data structures? I want you to just visualize the Excel sheet, right? Excel sheet is rows and columns, and everything is ordered, right? If you go to the far left of the Excel sheet, and let's say you're looking at Excel sheet of customers, you have customer 1 all the way down to customer 10,000. But how do we go from temporary storage to a table? You see, temporary storage does not have a particular structure. Moreover, it is not just used for the Excel application. All of your applications are using temporary storage. So how is the computer going from an almost random order of data to a nicely organized table? You know what you don't know is this: when you're scrolling through the Excel sheet, or when you're going from one sheet to the next, or when you switch from one application to the other, the computer has to pull data from different areas of the temporary storage and reassemble them in either a table or a window. But how do we get a table? How do we get that structure? Well, this is precisely what data structures are about. Data structures are about how we go from random and unorganized ordering of data in the temporary storage to ordered structure in the application. Okay? If you want to produce a table, a simple table like an Excel sheet, you must understand this component. I'll jump ahead for a moment, but I want you to look at this. If you're someone who hasn't written programming before, if you're someone who has zero knowledge of computer science, the most important topic for computer scientists is the one I'm about to tell you about now: data structures. Okay, and if you want to become a proficient programmer, where you can build advanced applications, where you can even become a software developer as a professional, where they hire you, this is a topic you have to be familiar with. In fact, when software companies are hiring people, the test they give you is tests about data structures. If you apply to Google and Facebook or any of these software companies, you will always be tested for your knowledge on data structures. They won't care about your degree. They won't care about your past employment. Right then and there, they want to see if you know data structures, because even people who graduate with computer science degrees, they may not have studied this topic very well. Okay? So for a software developer, for a programmer, for a coder, whatever you want to call it, it all boils down to this topic. We have two types of data structures: linear and nonlinear. Linear is straightforward. Linear means everything is ordered, like in a row or a column. So what type of data structure is an Excel sheet? It's a table. A table implies rows and columns. So it's a linear data structure. And linear data structures are prevalent. You see them everywhere. When you open your browser tab, those tabs are arranged in a row. That's a linear data structure. In your operating system, right? The start menu, when you have all your applications in the dock, that's a row, linear data structure. When you open your email and you're checking your email in your inbox, what do you see? You have the sidebar, right? With all of the emails that are coming through. It's like a column. right? So linear data structure. So they're prevalent. Then you have another category of data structures called nonlinear. And there are primarily two types of non-linear data structures, graphs and trees. This category is slightly more advanced than linear data structures. Social media applications use non-linear data structures for sending and receiving data. If you noticed, when you're on Twitter or Instagram or LinkedIn or Meetup, if that's how you found this event, when you scroll down the application, it seems to go on forever, right? It doesn't seem to, it's like an ocean. No matter how much you scroll, you will find posts. And we take this for granted. We take this capability for granted. But it is extraordinary that this is able to happen. Why is this extraordinary? You know, now some of us may be more active on social media, some of us not so. Some of us have a lot of friends, have a lot of pictures, have a lot of information on social media, and some not so much. But take an application like Twitter, right? Twitter, every second, there are at least hundreds of posts being made. Every second, there are hundreds of posts being made. There's a lot of volume of data, but we're able to go read past them in a split second. How is that possible? Traditionally, the way information has been stored is in a linear data structure, like a table. The problem is if you try to load a table for at even one person, it's going to take a while for that table to load, because that table can have my first name, my email, my address, my age, all of my friends, my favorite topics, my likes, my shares, my retweets. So if we wait for the application to load data for just one user, there's going to be at least 2-second delay. Imagine you do this for all of the hundreds of millions of users. It's going to take forever to load. Instead, what social media applications do, and this is not just limited to social media applications, they read the structure of the data is in the form of a graph. Okay? It's like imagine my social media information is a tree where the trunk is uh, my name and my last name and my email, and the branches are my connections, are my likes, my retweets. So, for example, and those branches could also be my posts, the latest posts I've made. So, the way social media applications work is they give you one branch at a time. They will give you one branch. And if you're interested in seeing the other branches, so for example, what my likes are, who my friends are, whenever you click on my information, on my profile, the application is going to give you more branches. So instead of trying to grab hold of the whole tree, so to speak, and give you the tree, which is, a lot of data, it will give you one branch at a time, leaves at a time. So, and nonlinear data structures are at the heart of the internet today. We want everything to be high speed. We want everything to be available. So in order for us to have high speed data, and data is now plenty, you need to understand how graph data structures work. So what I'm here, and here's my summary. Which program language should you start to learn? JavaScript or Python? JavaScript if you want to be an app developer, Python if you want to be a data scientist. And then once you learn the basics of these programming languages, what should you do next? Next thing you want to do is learn data structures. First, linear data structures. In fact, you have to if you want to learn the basics. Then, if you want to become more of an expert, you get into non-linear data structures. If you focus on these three things, you most certainly will be on your journey to becoming a professional, to the point where you can be hired and working for a company, and you'll be writing software for a living, or you'll be doing data science for a living. Okay. Let's see if I have anything else to add. Yes, one more thing. So JavaScript or Python, linear and then non-linear data structures. Now, in addition to learning these, in order for you to understand how these data structures work, you must understand the building blocks of programming languages. So remember that circle I showed you with all of those programming languages, and I said they all have something in common, which are called programming constructs. These are those programming constructs. These are the building blocks of a programming language, and all programming languages have them. And you must understand all 6 of these programming constructs. They include functions, variables, constants, control statements. So control statements is actually a category. We have things like if statements, switch statements, while statements. We have different types of data. We have strings, we have numbers, we have booleans, uh, we have arrays, we have dictionaries, lists. These are different types of data. And then the most advanced of these programming constructs are classes. Okay? So in your journey to learning programming languages, your destination is to become a master in data structures. But on your way to understanding data structures, you must make sure you master these 6 concepts. You must understand how they work. If you focus on these, you not only will understand how temporary storage will work, you will also be able to understand, read, and implement your own data structures. And this is how we become proficient. So in summary, let me summarize that again. Choose the JavaScript or Python. Start learning the programming constructs. Make sure you know all of them. You recognize them when you see them in a file. Make sure you should be able to recognize them immediately. Okay? And all programming languages have them. Then try to master linear data structures, and then finally master nonlinear data structures. If you accomplish these 4, then you're a professional. You're proficient. You're now a master. That's it for the slides. We have 10 more minutes. And like I said, I want to leave those 10 minutes for any questions that you have. Do you have any questions for me about what we covered? Or any questions before you joined or in general? You can turn on your microphone if you want. Sandeep, Katerina, Gauri Shankar, you have any questions? Now, there's only the 4 of us, so I have more time to answer your questions if you have any.
See, I have a question.
Yes.
See, in case if I wanted to learn JavaScript, see,
Yes.
I'm a designer.
Correct.
Okay. See, nowadays, people started asking for there's a basic programming knowledge for the designers as well. Okay. So if I wanted to learn JavaScript, how long will it take from the basic? But because I'm new to this programming language, I don't know anything.
Okay.
Of course, I have a basic understanding of HTML and CSS.
First of all, the fact that you're a designer, you already have leverage. Because if the company is interested in building applications, they want someone who understands how to translate designs into software, like how to turn a Figma. You may have heard of Figma. You probably know Figma. You're a designer, right? Or a Photoshop file. Turn the designs of the designer into software components. If you're a designer, you already have a lot of leverage. So there are 3 parts. There is the programming language, the syntax. Then you have the programming constructs, and then the data structures. Learning the syntax you can do in 2 weeks. If we're being generous, you can learn it. If you take your time, you can learn it in 2 weeks. In fact, that's what we do in the coding bootcamp. We spend 2 weeks just to familiarize people with the syntax. Okay. Then the data structures. The data structures. Let me pause here and say this before. How long it takes for you to learn a programming language depends on how you approach the subject. Most people do not have a method. For example, if I were to ask you to learn a programming language today, what would be the first place you would go to learn? So today you came to this meetup, but let's say we didn't have this meetup, or after this meetup, when you think about what would be your first destination? Which website would you go to learn a programming language? Tell me. YouTube, right?
Yes.
There. Even Katerina says YouTube. YouTube, right?
YouTube.
Or you would go to Google, and if the person who likes to read, you would read an article and follow along. YouTube is great if you want to learn the syntax, because we can watch and you can code along. So, but the problem is, when you want to get into the other two concepts, like those programming constructs and linear and the data structure, which are more advanced, YouTube is not going to cut it. So let me try to give you a short answer. If you can find, basically what I'm trying to say is this: how long it takes depends on your learning material. How long it takes depends on your learning material and your learning approach. If you can find a YouTube playlist or a YouTube channel that covers these three concepts I told you about, then that's what you should go with. It should take you 2 weeks to learn the programming, the syntax, 2-3 weeks to learn the programming constructs, and then it can take you, let's say, another 2-3 weeks to understand the data structures. Assuming you do this every day for at least an hour or two, you actually apply yourself. You don't just watch, but you actually code. You actually type whatever you're learning. So it is possible for you to do it in 2 months. Again, I'm not giving you this number based on, from my imagination. We've been doing a coding bootcamp for several years now. I think about 500 people have graduated, and these bootcamps are 2 months long. So if they can do it, you can do it too. If you have a proper learning approach, you can do it. For more advanced concepts, like if you want to be a professional, if you want to become a master, especially when it comes to data structures, maybe you're lucky and you can find a good YouTube video, but it's best if you get a textbook, a university textbook. Okay? The problem with online tutorials is that anyone can put them online. So you open a video and you hope that by the end of the video, your questions will be answered and everything that there is to know will be covered. It doesn't work that way. Sometimes the person who's recording a video wants to focus more on this topic than that topic. So some important concepts will be left out. And if you don't know what those concepts are, you won't know that you're not learning them. But if you get a textbook, the textbook will have a table of contents. So there are many books called data structure and algorithms. You have books from, it's a publisher, I don't know what the publisher is called, but it goes with, it says, for example, coding for dummies or finance for dummies, data structures for dummies. You have those elementary type textbooks, but you also have university level textbooks. I suggest if you really want to go in deep into it, you get a textbook. Why? Because textbooks, because they're used for university teaching, necessarily have to cover all the content topics. Even if you're not able to understand the topics, at least you would know, I need to know this, I need to know this, I need to know this. And if you go to a YouTube video and they cover it, okay, at least they're teaching this. And if they don't cover it, you would know. You would be aware of what you don't know and what you do know, which is very important. And you want to have a mix of material. You want to find some good textbooks and some good YouTube videos. Now, my number one recommended video learning resource is not YouTube, but LinkedIn Learning. LinkedIn Learning used to be called lynda.com. Then the company LinkedIn bought lynda.com. If you've never tried it before, you can get a 1 month free subscription. But even if you pay for it, it is absolutely worth the money. If you want to learn programming in a specific time frame, like you have decided, I want to learn this, and I want to learn it this year, LinkedIn Learning is the best investment you can make, because YouTube is random. You don't know who the YouTuber is. You don't know what they're teaching. You don't know their expertise level. In many cases, the information is wrong. I've seen it myself. But with LinkedIn Learning, there is quality assurance, there is consistency, and if your decision is to learn in a month or 2 months, and you have to learn this, and you've made this decision, go with LinkedIn Learning. That should be your number one resource. If LinkedIn Learning doesn't work, then you would try other resources. So there is that. Katerina, do you have any questions? Any questions from you? And Gorishankar, if you have, if that answers your question, great. If another question, I can answer it for you as well.
No, I'm good. Thanks.
Excellent. Very well then. Nonetheless, if you have any questions after this workshop, you can email me. I'll be happy to answer any questions you have. Do stay in tune with Meetup because we have more events coming, especially in September. We have a data science series. And there will be workshops, 1 hour, free. I'm sure you will also benefit from attending those workshops. That's it for today's workshop. Thank you for joining me.
Thanks, Nick. Thanks for your time.
You're most welcome. If you have any questions afterwards, again, this is my email. But for now, I want you to enjoy your evening, and I hope to see you in another workshop. Take care and bye-bye.
Bye-bye. Thank you. Bye.